So with that annexation, let's continue from where we stopped previously. So previously we stopped at question number 36. So let's continue from there. So question number 36 sounds like this. Diagram below show the structure of the type of silicate. Which of the following statement is correct with regard of the above structure? So in here, the question is trying to tells you that this is a single chain silicate where it is a pyroxene. So the repeating unit of this is SiO3 2-, and the ratio of the silicon to oxygen is 1:3. So this is the structure for the silicates found in the pyroxene. So 36 is C. 37, the thermostable liquids MCl4 reacts with water to form a solution with a low pH. So this low pH is actually the formations of the HCl for your information. So which statement about M or its oxide is true? Okay, so M is as acidic oxide, so which is uncertain because M can be SiCl4 or GeCl4, because these are the only two chlorides that are thermally stable in here. So because the question says it's thermally stable, so it might be silicon or germanium, and then it react with water, which is acidic hydrolysis, so it form a value of low pH. Okay, so A, MO is an acidic oxide, so it's either a neutral or amphoteric, so A is wrong. So B, MO can exist as a simple covalent molecule, which may be true for silicon. And then MO2 is a reducing agent, so MO2 cannot act as a reducing agent because MO2 is stable for both silicon and germanium. And finally, M is a good electrical conductor, so in here, both silicon and germaniums are semiconductors in here. So therefore, the best that describe that MO exists as a simple covalent molecule. Okay, so the best answer in 37 in here is B. Okay, so with annexation, let's go to question number 38. Solder is an alloy which is made of tin and lead. Which of the following is the main role of the tin in the solder? So the purpose of the tin in the solder is to act as a resistance to corrosion, and it is naturally coated with the oxide layer. So the best answer for 38 is C. And 39. The bond in the CCl4 and SiCl4 are 349 and 330 kilojoule Kelvin respectively. Which statements explain the difference of their boiling point? So this is due to the small size of CCl4 and SiCl4. So therefore, the CCl4 has a stronger intermolecular forces than the SiCl4. Okay, so the best answer in here is D. Okay. Anything? Okay, so that's for question number 39. And then we go for the last objective question, which is 40. The structure of a material represents the diagram below. So this one is, you can obviously tell that it is a graphite here. So which part is true about this material? It conducts electricity, which is true. So it has a low melting point. No, it has a high melting point. It is soluble in organic solvents. So it is insoluble because it has a giant covalent structure in here. And it forms CO2 and H2O. So when graphite is burned, it only forms carbon dioxide. So the best answer in 40 is A. Okay, so with that, that is all for the 40 objective questions that I have for you. So with that annexation, let's continue with the essay question, structure questions, shall we? So we are moving to the section B, which is the structure question. So question number 1 sounds like this. Tetrachloride of the group 14 element are exemplified by CCl4, SiCl4, GeCl4, SnCl4, and PbCl4 are all volatile liquid under standard temperature pressure. A. Draw the Lewis structure of CCl4 and state the molecular shape of CCl4. So the shape is a tetrahedral, and the Lewis structure looks like this. Lone pair electron must be included because the question asks for Lewis structure. So the Lewis structure must contain the lone pair electron in there. Okay, B, all tetrachloride with exception of CCl4 are hydrolyzed in aqueous solution to form acidic. Using SiCl4 as example, write a balance equation for the hydrolysis reactions. So in here, you have to write the balance equation of SiCl4 plus 2H2O give SiO2 plus 4HCl. And number 2, explain why CCl4 do not undergo hydrolysis. So this is because carbon, which is from group 2, does not have empty orbital. Therefore, it does not allow the water to coordinate the dative bond to the center metal atom. Because if you allow the water order to coordinate. That means that carbon will have more than 8 bonds, which is impossible for the carbons in here. Okay, so that is for number 1B. And then we have 1C. What are group 14 tetrachloride undergo decomposition even under room temperature? State which chloride, group 14 tetrachloride that decompose under room temperature. There's only one answer to that, which is PbCl4. So PbCl4 is a very unstable because Pb is more stable as a +2 oxidation state. Okay, so write the equation for the decomposition as mentioned. So PbCl4 will become PbCl2 plus Cl2. So the reason behind why PbCl2 is more stable is due to the inert pair effects in here. So hopefully you can understand. Okay, so that is for question number 1. Then question number 2, germanium is one of the alternative material used as a semiconductor in the electronic industry. For this purpose, germanium is used to have the highest purity. So the purified germanium, impure germanium is first converted to a more volatile germanium tetrachloride by passing through impure germanium with heated chlorine. So write a balance equation for the reaction between impure germanium with chlorine gas to form a germanium tetrachloride. So you have Ge plus 2Cl2 give GeCl4. And number 2, explain why germanium tetrachloride is a volatile liquid. Now in here, the question whenever they try to ask you why is it volatile, so it must have something to do with the intermolecular forces. So whenever you are answering for this question, you must always mention that germanium tetrachloride is a simple covalent molecule held by the weak van der Waals forces. So that is why it is volatile in here. Then we have B. After germanium tetrachloride is formed, then it's passed through hydrogen gas to form the pure germanium. Write a balance equation for the reaction between germanium tetrachloride and hydrogen gas to form back the pure germanium. So you have GCl4 plus 2H2 gives Ge plus 4HCl. Now in this case, the question already described to you clearly on how is the reactions where germanium tetrachloride is passed through the hydrogen gas to form the pure germanium in here. So you just follow exactly what the question has described, and you will more or less expect what is the product that is formed from these reactions in here. Okay, then we have C. Based on the equation in B1, state the observation for this reaction. So because you form HCl as a side product, so you observe white film. Okay, and suggest 2 methods to increase the conductivity of germanium as a semiconductor. So you have only 2 methods, either one by doping with phosphorus or boron, or you increase the temperature in here. Okay. Okay, so that is for how you're going to answer for question number 2. So immediately we go to question number 3. How does question number 3 sounds like? 2 most common oxide of lead are lead-2 oxide and lead-4 oxide. Lead-2 oxide dissolve readily in aqueous nitric acid, while lead-4 oxide react with concentrated hydrochloric acid to form lead-2 chloride and chlorine. 1. Write a balance equation for the reaction between lead-2 chloride and aqueous nitric acid. So this is basically an acid-base reaction because we know that lead-2 chloride is amphoteric, which can react with both acid and also base. So therefore, the equations that react with the nitric acid is PbO plus 2HNO3 give PbNO3 2 plus H2O. So it must be balanced here. Okay, number 2, what is the property shown by the lead-2 oxide in this case? So in this case, lead-2 oxide acts as a proton acceptor, therefore a Bronsted-Lowry base. Okay. Number 3, write a balance equation for the reaction between lead-4 oxide and concentrated hydrochloric acid. So you have to write a balance equation of PbO2 plus 4HCl with PbCl2 plus Cl2 plus 2H2O. So this is then in this case, state the oxidation changes in the lead in this reaction. So it changes from +4 to +2. And what is the property shown by lead-4 oxide in this reaction? So lead-4 oxide shows that it is an oxidizing agent. Okay, because it reduced to become +2 oxidation states. And finally, number 6, state and explain the relative stability of the lead-2 and lead-4. So you're going to state that lead-2 oxide is more stable than lead-4 oxide. Why? Due to the inert pair effects in lead. So you have to explain why is it that the lead-2 chloride, lead-2 ions is more stable than the lead-4 ions in here. Okay, so that is for number 3. Immediately we go to number 4. Silicone compounds are mainly used in making glass. The most common and cheapest glass is soda glass, which is manufactured by mixing sand, which contain mainly silicon dioxide, sodium carbonate, and limestone, which is calcium carbonate. State the component of the soda glass and write the equations for the reactions involved. So in here you may have a mixture of sodium carbonate, lime carbonate, and the silicon dioxide, which eventually will become silicate according to the equation. So it's either sodium silicate, Na2SiO3 or calcium silicate CaSiO3. So the equations for the balanced reactions is SiO2 plus Na2CO3 from Na2SiO3 plus CO2, or you have SiO2 plus CaCO3 gives CaSiO3 plus CO2. Number 2, state 2 properties of the soda glass that suits to its application as a bottling glass. So either you can say that it is chemically inert, it has low heat expansion, or it has low melting point, or it is resistant to corrosion of acid and base also can. We can also even include this inside your answer. So this is also an additional reason why it is suitable to be used as a storing bottle in the glass here. Okay, B. Boron is added to soda glass in order to enhance the properties of the soda glass. State the main component of borosilicate glass and write the equation for the reactions involved. So the component that acts in here is a boron silicate, B2SiO3, and according to the equation, 3SiO2 plus B2O3, you form B2SiO3. Okay, so number 2, state one application of the borosilicate glass in the daily life. So it's either glassware in the science laboratory or glass kettle. Either one can. Okay, so with that, that is how you solve for question number 4. Immediately, we move to question number 5. Silicone are oil and rubber-like materials used commercially in a wide variety of the product. Commercial silicone has infinite OSIO chain with LQ or aryl group attached to the silicone atom. A. Draw the structure of chain silicone showing 3 repeating unit with a methyl CH3 group. So you have to show in 3 repeating unit. So the repeating unit is looking at the SI chain in here. So if the question said you must have 3 repeating unit, that means you must have the 3 organosiloxane. Organosiloxane is between Si and C bonds in here. So lack of any one will deduct 1 marks in here. Okay, so this is the repeating unit of the silicone chain in here. B, state 2 properties of the silicone. So you have quite a few number of properties. Insoluble in water, non-toxic, stable to heat, stable to chemical substance, or stable to acid and base. So all of these are properties inside the silicone. So you can write any 2 inside here, so that will give you the 2 marks. And C, explain why silicone is used in the manufacture of waterproof fabric. So in here you have oxygens. So the oxygens in here will form hydrogen bond with the fabric, because fabric are mainly made of a cellulose which contain OH bond inside them. So or AH bond inside them. So silicone contain the hydrophobic LQ group. So this will become the water. This will form the barrier to repel water. Or it can act as a water repellent in here. Okay, so this is how the silicones are applied in the fabrics to make hydrophobic properties inside here. Okay. Okay, so that is how you are going to answer for question number 5. Immediately, we move to question number 6. The part of the structure of group rocks of forming silicate mineral is found in many igneous and metamorphic rock is shown in the diagram below. So this is obviously a cyclosilicate. So write the structure of the basic structural unit found in the silicate mineral. So the questions want the basic unit, basic structural unit. So the basic structural unit in here is SiO4 minus. Number 2, state the common characteristic presence in the silicate mineral. Explain your answer. So in here, you must write that 3 basic silicate joined together, where each silicate share 2 of its oxygen atom to form a cycle structure. Okay, so these are the 2 properties, characteristics present in these silicate minerals. And 3, name the group silicate with the structure above. This is a cyclosilicate or ring silicate also can. Okay, so that is for 6A, and then we also have 6B. Part of the structure of silicate mineral found in the rock is shown below. So this is obviously a silicate sheet. So where are the repeating unit in here? So if you look carefully, where are the repeating unit? The repeating unit is located somewhere in between here. Okay, so this is one repeating unit of the silicates. So what is the property? What is the common characteristic presence in this silicate mineral? Explain your answer. So in here, three corners of the SiO44 are shared together by three oxygen atoms to form a two-dimensional infinite sheets in here. So in another word, each silicate share three oxygen atoms to form a single layer structures in here. Number three, state an examples application of this mineral. It can be mica, it can be talcum, it can be kaolin. So either ones are accepted inside here. Okay, and for your informations, the repeating unit for this silicate sheets is Si2O52 minus in here. Okay. Okay, so with that, that is how you are going to answer for question number 6. So immediately we move to question number 7. Using the following set of axes to sketch the graph of the variation in melting point, ionization energy, and electrical conductivity, hence explain its properties as deduced in the graph. So we are going to assume that carbon is the allotropy of diamond. Okay, so in terms of melting point, how should the graph look like? So the graph looks like high and then decrease from silicon to germanium, and then tin, and then lead has a slightly higher melting point. So sketching this line has 1 mark. So you have to mention that carbon, silicon, germanium are giant covalent structure molecule, whereas tin and lead are metallic bonds. So that is how you are going to describe them. Okay, if you want to write more, go ahead. You want to write why is it that the carbon, silicon, germanium decrease. So this is due to the atomic radius increase. So when atomic radius increase, it will increase the bond length, hence decrease the bond strength, therefore easier for them to break. Okay, whereas tin and lead, why lead has a slightly higher metallic bond, it is due to the cubic close spec, hexagonal close spec structure inside the lead. So it has a greater density than that of the tin. So that is why lead has a higher melting point compared to tin. Okay, so that is for 7A. Then we move to 7B in terms of ionization energy, generally decreased, but when it comes to lead, it is slightly increased. So why is the first ionization energy? Because effective nuclear charge increase as the screening effect increase. So furthermore, this lead has a ineffective screening of the 4f orbitals, which is the reason why lead has a slightly higher first ionization energy compared to tin. Okay, in terms of electrical conductivity, carbon, as in diamond, has a low electrical conductivity, which is an insulator. Silicon and germanium are semiconductor, where tin and lead are conductor electricity. Okay, sorry, the line may be slightly wrong in here. Supposedly from germanium, tin and lead like this. Okay, so can you please help me to correct this one? I'm so sorry for all the inconvenience caused. It's supposedly to be like this. Sorry, and we're going to add in this. Sorry for the mistakes in here. Okay, so this is how electrical conductivity should look like here. Okay. Sorry for the minor mistakes that I made in the slides here. So hope that you'll be able to understand well. Okay. Okay, so with that, that is the 3 graph of the group 14 physical properties. Okay, so hope that you can answer better in the future. Okay, with that annexation, let's move on to our final structure questions. So our final structure questions is question number 8. The formula of the melting point of some oxide of group 14 are given below. You have carbon, CO2, which is -78, and then tin, SNO2 is 1630. Describe the bonding in each oxide and how is it related to its melting point. So carbon dioxide is a simple covalent molecule held by weak van der Waals forces, while tinfoil oxide is a giant ionic crystal lattice. It's an ionic compound held by strong electrostatic attraction forces in a giant ionic crystal lattice structure. So that is why it exhibits a very, very high melting point in here. Okay, so that is for 8A, and then we get B. Write the equation, if any, for the reaction of CO2 and SNO2 with the aqueous solution of the sodium hydroxide and hydrochloric acid. So carbon dioxide is acidic, so you only have 1 mark in here. So tin 4 oxide can also react with sodium hydroxide to form Na2SNOH6. Whereas hydrochloric acid does not react with carbon dioxide, whereas SNO2 react with 4HCl to give SnCl4 plus 2H2O. So that will be the properties of both carbon dioxide and silicon dioxide when dissolved in aqueous sodium hydroxide and also hydrochloric acid. Okay, so that is all for the structure questions. I think we still have more times to do one essay, so we'll do one essay. Okay, so let's have a look at the section C. We do one essay questions. Okay, so essay questions number 1 sounds like this. Group 14 is the only group in the periodic table that consists of all metal, non-metal, and metalloid. They exhibit varieties in physical properties descending to the group. Suggest explanation of this physical properties trend in terms of the structure and bonding of group 14 element as exemplified by carbon as in diamond, silicon, germanium, tin, and lead. A. Atomic radius descending group 14. So you must mention that atomic radius increase when going down group 14. Why? Because new number of shell or screening effect increase, which increase the effective nuclear charge. Whereas in terms of melting point, so you have to mention that carbon, silicon, germanium are giant covalent structure. So the atomic radius increase from carbon to silicon to germanium. Therefore, the bond strength increase, causing the melting point to decrease from carbon to silicon to germanium, whereas tin and lead are held by metallic bond. So that is all the 4 key points that you have to mention for tin and lead. Okay, so you notice that when it comes to Stpm question, there will be more or less asking around all this. Okay, so that is for 1A and 1B, and then we have 1C, ionization energy of group 14. So generally, ionization of energy decrease. Why? Because atomic radius increase down group 14 as the effective nuclear charge increase due to the as a student, you should also write that as nuclear charge increase. Increase with the reduction. Okay, and finally, you should also explain why is it that ionization of lead is higher than tin due to the ineffective shielding of the 4f orbitals in here. Okay, so as a student, you just write everything that you know about how to explain the ionization energy. And last but not least, in terms of conductivity, so conductivity increase when going down group 14. Carbon is the insulator as there is no delocalized electron by the carbon. Silicon and germanium are semiconductor with a small energy band gaps between the conduction and valence band. And finally, tin and lead are conductor because they are metals that can delocalize electrons. Okay, so some of you might have puzzled. So teacher, can we use a graph to represent and then explain the properties inside there? Yes, you can, no problem. You can always use any forms that you want in order to explain your essay questions. Okay, so we still have one more time to go. We still have enough time to go for one more essay, so we'll go for the second essay questions. So let's go to the second essay questions. The relative stability of the oxide of group 14 elements in the periodic table are shown in the graph below. So that is the relative stability graph. Explain the trend of the relative stability of the oxide of group 14 in the graph above. Okay, so whenever you are trying to, no matter you are trying to explain the relative stability of the +2 and +4 oxidation states, or you are going to explain the acid-base properties of the +2 and +4 oxidation state, you must always start with these 2 statements. I've already stressed this quite a number of times. So the 2 important statements that you must always state is number 1, all group 14 has the formula of MO and MO2 with the +2 and +4 oxidation state relative +2 and +4 oxidation state respectively. Okay, I repeat, you must always have the formula says that all group 14 can exhibit formula MO and MO2 with +2 and +4 oxidation states. Okay, only then you start to explain the trend. So when going down to the Group 14, the +2 oxidation state stability increase or +4 oxidation state stability decrease, either one. Huh? So why? So in this case, you can use carbon as an initial, this one. So carbon dioxide is more stable than carbon, as the valence electronic configuration of all group 14 is NS2 and NP2. So in +4 oxidation state, group 14's elements are bonded to oxygen by covalent bond, and then the strength of the covalent bond weaker as the atomic size increase. So furthermore, lead has a +2 oxidation state changes from covalent to ionic due to the inert pair effect. So lead has a extremely stable +2 oxidation state due to the inert pair effects inside them. Okay, so so try your best to describe. I also already described how to answer this structure stability of the +2 and +4 when I explain the notes. So you can maybe browse back at the notes and then you try your best to explain. Okay, so that is for 2A. Okay, then we go for 2B. Discuss the acid-base properties of the oxide of group 14 in a +4 oxidation state. The question only one +4 oxidation states. So make sure that you only highlighted the +4. Okay, so how is the properties? So in here, similarly, you just explain CO and SiO are neutral. Sorry, I think I made a mistake in here. No need to explain this. Sorry, no need to explain this. Can I correct it for a while? Sorry. So we have to mention that 7 marks. Okay. Acidity. Okay, sorry for that 2 points in here. Okay. So you have to generally describe the acidity of MO2 decrease when going down group 14, okay, as the ionic properties increase or the basic property decrease as atomic radius increase. So only then you start to describe CO2 and SiO2 are acidic. So you use any one examples, you write the equation, SiO2 plus 2OH minus give SiO3 2 minus plus H2O. And then GO2, SNO2, PbO2 are amphoteric. So you write any equations that represents the amphoteric properties. For example, MO2 plus 2OH minus plus 2H2O give MOH6 2 minus, or you use MO2 plus 2OH minus give MO3 2 minus, but actually the first one is better. And last but not least, as a base, NO2 react with acid to form N4 plus 2H2O. Okay. Okay, so I guess that is all for our lesson for today. So I hope that you can slightly get better on how to answer the group 14s. So tomorrow we shall continue more with the group 14 essay questions. So I guess that is all for our lesson for today.